Hi, this is Mrs. Herrera here with the classwork for April 29th. This would be 5.2.8 in Google Classroom. We're going to be interpreting a polynomial function. And so we're given a function f of x is equal to the quantity x minus 1 squared times x plus 2. So they don't give us a picture, but I'm going to draw a picture immediately so that I can answer the questions. They want to know, select which of the following statements are true about this given function. So what we know here is because this factor is squared, that our graph is tangent where x is positive 1, because we would set this equal to 0. So it's tangent at positive 1, and it crosses the x-axis at, we would set this equal to 0, and so x equals negative 2. So it crosses at x equals negative 2, and it's tangent where x is positive 1. I know that a positive function ends up positively. So it ends up, it is tangent at 1, and it crosses at negative 2. Now these loops, it might be a little higher here, but that is the basic shape. So let's utilize that and let's respond to the following answers. It says the x-intercepts are positive 1 and negative 2. Well, in fact, your intercepts are exactly that, and we got those from the function. So that is true. Let's circle A. B says the x-intercepts are negative 1 and positive 2. And with that, they're saying, do you not know that the factor and the intercept are opposites? And if you knew that, you would know right off the bat that B is not true. Option C says the graph crosses the x-axis at positive 1 and is tangent at negative 2. So here they're utilizing these two. They have the two intercepts, but they're trying to confuse you and preying on the fact that maybe you don't know that a squared term is tangent, okay? They're saying it's tangent at the x minus is equal to negative 2 when it's reversed, so it's not C. Looking at D, the graph crosses the x-axis where x is negative 1, and its tangent at x is positive 2. Well, again, you can go back and look at our picture now that we've drawn that. That is not the case. Looking at letter E, the graph is tangent where x is positive 1, and it crosses where x is negative 2. That is absolutely the case. Okay, so we're going to circle E. Letter F, the graph is tangent at x is never equal to negative 1, and it crosses at x, the x-axis at x equals 2. And again, we can look at the graph, and that is not the case. Letter G, almost done here. G says a local minimum. Now remember, the local minimum, a graph can have one, it does not have to have one. But they're saying the local minimum occurs, sorry, my glasses. The local minimum occurs on the interval between negative 2 and positive 1. Local minimum between negative 2 and positive 1. Well, we do have a local minimum, but it's not less than 1. It's exactly at 1. And so that is not true. When we go to letter H, a local maximum is on the interval between negative 2 and 1. Let me go back. A local maximum is on the interval between negative 2 and 1. All right, that's true. And it's got a local minimum at x equals 1. So again, it's saying the maximum occurs between these values, negative 2 and 1, which in fact it does. It's a local maximum. And the local minimum occurs exactly here. Now, why is this a local maximum? Because it only is a maximum here. The graph has higher values if I go further down where x's increase. And again, this is a local minimum. It's not a global minimum because at some point later on, my graph is in fact at a lower y value. All right, so H is true. I says local minimum on the interval between negative 1 and 2. Local minimum, and we know that's a local max, so let's just stop. That's not true. Going to J, there's a local maximum on the interval between negative 1 and 2. All right, well, that is true. And there's a local minimum at x equals 2. Hang on a minute. There's a local max on the interval between negative 1 and 2, and a local minimum at x equals 2. That one also is true. I didn't circle that one. Oh gosh, that's letter J. Letter J. Local max and a local min at x equals 2. All right, so they're saying these things in slightly different ways. Again, critical thinking, reading skills. All right, when we go on, we have another question, number 19 and number 20. So let's take a look at number 19. They give a function f of x is equal to x squared times the quantity x minus 3. That's given. So what do I know? I know it's a cubic because I have x squared and I have x to the first, so that gives me x cubed. So I know one arm is up, one arm is down. Odd degree equals opposite direction and behaviors. What else do I know? I need to set that x squared equal to 0 and set the x minus 3 equal to 0 to locate the x-intercepts. And then they're going to give us this function, and they're going to say, well, what's wrong? Well, taking a look at it, even before I find the x-intercepts, we see that the x squared, we know that x is 0. So since it's squared, it's tangent at x is 0. Take a look at that. I do not see tangent at x equals 0. I see it crossing the axis. So that's a mistake. And then x minus 3 would be x equals 3 for the intercept, and it should be crossing the x-axis at x equals 3, and it is not. So they ask you to make the correction. So what I've done first is I set x squared equal to 0, square root of both sides. X equals 0 is a tangent. And what else do we need to know? We set the x minus 3 equal to 0, x equals 3. And what I did was I put those two dots. Since it's a positive polynomial, positive odd function, it has to end heading towards positive infinity. So I knew that arm was up and the beginning end behavior is down. Okay, so that's our solution. Again, this might be lower when I do the actual graph on a graphing calculator, but that's the basic shape of the graph I'm looking for. Let's take a look at number 20. Now, you're given what's called a quintic, which is kind of hard to say, but it's something x to the 5th power, a function whose degree is 5. And so I have x squared in the beginning. There's 2. There's your third x, and this is 2x squared. So when you multiply those all together, you get the x to the 5th, which is an odd function. So I have one arm up, one arm down for end behavior. Also, since my leading coefficient is positive, it ends on a positive. So again, I have to end up, and I'm going to start down. Okay, what we need to do is set each of those factors equal to 0. So x squared equals 0, so x is 0, and we know it's tangent. Why? Because it's a squared term. This is not a squared term, so it's going to pierce the x-axis. If you set this equal to 0, you would minus 2 to both sides. So x is negative 2, and it crosses at negative 2. And lastly, this is a squared term, therefore it is a tangent for the polynomial graph. So you would set x minus 2 equals 0, add 2 to both sides. So x equals positive 2 is the a tangent, again, because it's a squared term. So take a look at the graph I have. We know that it has to pierce through at 2. It needs to be tangent at 0. It needs to be tangent again at 2. Now this loop in here might be higher, and this might be shooting up higher, or it could be a little bit lower when I actually graph it, but that is the basic shape. And again, we're taking it piece by piece and sort of deconstructing the polynomial so that we can sketch it. That's number 20. Okay, I'm done for today. I told you I'm trying to keep my videos all within 10 minutes so that you have time to do the sketches and to submit in Google Classroom. Everybody have a good night. Also, again, one last thing, any questions, please message me.